Thank you for stopping by. Today we're going to jump into an example for how to solve a limit numerically. And first we have to understand what they're asking us. What is the limit as x approaches 1 of this function, x cubed minus 1 over x minus 1? And so let's take a look really quick at a number line. And let's put our value of interest in the middle, 1. So now what we're going to say is, well, we already know a few things. If we plug in 1, we get 0 in the numerator, and we also end up getting 0 in the denominator. So we can't do that. There's something weird going on at that point. So we know that simply plugging in a 1 is going to give us an undefined value. And I'm going to put it right here. I'm going to say if my x is 1, my limit is, or my value here is going to be undefined. So what it's usually customary to do is to look at what's going on the left and what's going on the right of this function. We know that at 1, we have this undefined. So let's see what's happening at 0. Now when we plug in 0, we get 0 minus 1 equals negative 1. 0 minus 1 equals negative 1, and we get 1. So the value of this function at 0 is 1. Now let's look at what's happening on this side of the function. On this side of the function, that means the value would be 2. What is happening at 2? So if we do that, if we plug in 2, we're going to get 8 minus 1 on the numerator, and we're going to get 2 minus 1 on the denominator, and we end up getting 7 over 1, or just 7. What my function is doing at 1, I am not sure. But we can always zoom in this number line. We can always take this number line here and just stretch it out and see what's happening closer to 1. And if we do that, we end up still with a value of 1 in the middle. But if we get really close, you're going to notice that this might be 1.1, and this over here might be 0.9. And as we do that, we keep getting closer and closer and closer. So the way we're going to do this is we're actually going to pick these really close values, and these are going to be the outermost values that we're going to pick. Meaning we're going to go to our table here, and we're saying, well, at 1, it's undefined. And the furthest I want to go to the left from this 1 is 0.9, because that's as close as I want to get, or as far as I want to get. And the furthest I want to get to the right from this 1 is going to be 1.1. Now we keep zooming in. Eventually we're going to get to a point where we're going to get to the hundredths. So this might be 0.99, and this right here will be 1.01 as the furthest away. And so that's what we're going to choose. We're going to say, well, this is going to be 1.01, and the next closest one is going to be 0.99. And you can see where we're going with this. The next closest value to 1 is going to be 0.999. And the next closest value on this side of 1 is going to be 1.001, just a little bit over the 1. And this is what we're going to use to figure out our limit. What is our function doing as we keep getting closer and closer and closer to 1? And so we're going to start with that, and we're going to start with our outermost values. And we're going to plug them in here. And we're going to say this is equal to 1.1 cubed minus 1 over 1.1 minus 1. 1.1 cubed is the same thing as 11 cubed, and then you just put the 3 decimal places. So this is just going to be 1331 with 3 decimal places, so 1.331 minus 1 over 0.1. 1.331 minus 1 is going to be 0.331 over 0.1. This is simply saying 0.331 divided by 1/10 or multiplied by 10. So you can say this one right here is 3.31. Doing the same thing with the 0.9, we're simply going to say 0.9 cubed minus 1 over 0.9 minus 1. Now 0.9 cubed is simply 9 cubed with 3 decimal places. And 9 cubed is 729, so we get 0.729 minus 1 over 0.9 minus 1. And 0.729 minus 1 is going to give us 0.2 0.71 negative over negative 0.1. And this is the same thing as multiplying by 10, and they're both negative, so it's going to be positive. So this would be 2.71. Now we can keep doing this by hand, but you can see how tedious it can get. So what we're going to do is we're going to use a calculator, and we can compute it by putting values in and actually calculate them. Or if you have one of those TI-84 or the graphing calculators that have a table, I will show you how to do it right now. First, you're going to go into y equals. And in y equals, you are going to put in this function. y1 equals, open parentheses, x cubed minus 1, close parentheses, divided by, open parentheses, x minus 1. Close parentheses, press enter. And then you're simply going to go to second again. And then the button that says graph. You will notice that above it says table. So you're going to go to second and table. Now, depending on whether you have any inputs or you change anything in your table, you might already have some values in there. So what we're going to do is we're going to go to the X column and highlight the 1. Make sure the 1 is highlighted. And you're going to press plus. Now, you're going to see the table is going to be a little triangle with the table. It means the change in the table. And we're, for now, going to put 1. And enter. And this just means that the x value grows by 1. And you can see that right above the x value 0, and it gives the y value of 1, which is what we had before. At x equals 1, our y1 is error, which we already know. And at x equals 2, our y1 is 7, which we already calculated previously. Now, highlight the 1, or just make sure that the 1 is highlighted because it should already be highlighted. And go ahead and press plus. And now we're going to enter our second interval, which is 0.9 just for verification, but our interval is going to be 0.1 because that's the step that is changing. It's changing by 0.1 every time. And you can see that when the x value is 0.9, the y value is 2.71. And when the x value is 1.1, our y value is 3.31. So that works. Now, make sure that the 1 is highlighted again and go press plus. And now your delta table is going to be 0.01. So now we're going into the hundredths territory. Enter. Now you can see that when x equals 0.99, our y1 is 2.97. 2.9701. I'll go ahead and put in all those. And when x equals 1.01, our y value is 3.0301. 0301. Now we can continue. So make sure the 1 is highlighted. Press plus. And now we're going to enter our final value here, our final step, which is going to be 0.001. You can see that above our x equals 1 is our 0.999. And our y value is 2.997. So then we're going to say 2.997. And if we look into the x values, 1.001, we get a value of 3.003 for y. So here's 3.003. You can see that when our x values are getting really close to 1 from either side, our y value tends to go on either side to 3. And so even though f of x is not defined at 1, the limit that each side approaches as we approach 1 from either side is this value, and it looks like it's going to be 3. So we write it and we generalize it like this. We say the limit as x approaches 1 of this function equals 3. That is all for today's lesson. I hope you liked the video. I hope you learned something. If you did, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. And if you have any questions, comments, concerns, or emotional outbursts, make sure to drop them in the comments below. Thank you so much.